Hello and welcome back. We have seen how to build a model and how to measure the accuracy of a model. When data set is imbalanced, we know that accuracy should not be used as a metric to understand model's performance and get cheated. Right? So we have seen F1 score, precision, and recall. But when you look at F1 score, it always favors the models which have got the precision and recall scores close to each other. Suppose that you built three models, maybe logistic regression, SVM, and random forest. And SVM is giving you the precision and recall close to each other, right? Maybe 90% and 91%. And the logistic regression and the random forest models are giving precision recall far from each other, maybe 75% and 90% and 78% and 92%. Then we try to calculate F1 scores. The SVM's F1 score will give you high because the precision and recall scores are close to each other, right? So this gives you a kind of wrong impression, one thing. And the second thing is, in all real-time cases, you will not get the precision recall scores close to each other. And in sometimes we may need the model, give more precision, and in some cases we may need model to give high recall. The two examples here we are using are food predictor and heart attack predictor. If you are trying to build a application to predict whether food is good or not, healthy or not, that model should always give high precision, because whatever the algorithm predicts as good food should be good, right? It should predict 100% correct. It never should predict a bad food as good food, because it's going to harm the person's health who is actually using your application to make the decision and take the food, right? So there the model should give high precision. And when you are trying to build a heart attack predictor, recall should be high, because when you are predicting somebody is prone to get heart attack, that means in the real data set, how many heart attack patients are there, all should be predicted as heart attack. Heart attack prone people are heart attack they'll get it in future. If you don't do that, some people may take it easy and eat not in a proper order and don't do exercise, and they may get into trouble. So the heart attack predictor should give high recall. That means when you are building a model, in the data set, whatever positive records are, heart attack records are, the records belonging to heart attack should be predicted as heart attack patients only, or heart attack prone patients only. And all the positive records should be predicted as positive. That is recall. When you actually use the model in the production, right, it may actually do that. Or in sometimes it may actually predict who is not prone also as prone, but that's not going to harm anything, because the person who knows that he is prone to heart attack, he or she may actually do more exercise and eat consciously and things like that. So these are the examples, and in coming classes we will understand how to play with precision and recall, or you can actually increase the precision or decrease the recall, or increase recall and decrease precision. It is called as precision recall trade-off. When you actually do that, you can make the model work as you like. If you are building a food predictor, right, you can make the model give high precision. If you are building a heart attack predictor, you can make the model give high recall. So this we call it as taking control over the model or the algorithm. So we'll see that in coming classes. After understanding logistic regression and threshold, we'll explain you with practical examples. Visually we'll try to show you. Thank you.